they are from. Design United also firmly believes in an interdisciplinary design conversation and collaboration and cross-pollination of ideas. We've also had brilliant mentors, regional designers with great expertise and commitment to mentoring younger generation of designers. So please continue to join us every week on Saturdays, same time at 4:30 for the conversation. With this background to Design United, let's move to the much anticipated presentation and conversation this evening. I'm truly honored to welcome our presenting structural designers, renowned structural engineer, Mr. Deepal Wickremasinghe, joining us from Colombo, Sri Lanka, and innovative Indian structural designer, Mr. Manjunath BL, joining us from Bengaluru, India. Mr. Deepal Wickremasinghe of Deepal Wickremasinghe Associates Private Limited, civil and structural consultants, has over 38 years of experience and is the founder member of the Society of Structural Engineers, Sri Lanka, founded in 1990. He has contributed greatly to several remarkable built projects in Sri Lanka, collaborating with leading architects. He has also taught as a visiting lecturer at Sri Lanka Institute of Architects for 10 years. 1990 onwards, he had the fortunate opportunity of working with legendary Sri Lankan master architect Jeffrey Bawa on 3 major hospitality projects, including the remarkable Kandalama Hotel, which has been recognized with numerous awards internationally. Architect Jeffrey Bawa's testimonial about Kandalama Hotel, architect Jeffrey Bawa states, "From the onset of this project, Deepal showed remarkable prowess in his ability to understand and execute sometimes nearly impossible thoughts that occurred to me as the architect in this project." End quote. Indeed, Mr. Deepal is not only a brilliant engineer, but is also extremely encouraging towards emerging designers and students of design. I'm extremely grateful he has joined our DU mentorship series today, and I take this opportunity to welcome him to Design Conversation. I'm also privileged to introduce and welcome innovative Indian structural engineer, Mr. BL Manjunath. Mr. BL Manjunath will be joining us today from Bangalore. He started his practice in 1994, having collaborated with leading designers from across India and abroad towards building projects within India. He is seen as a conceptual co-author as much as a consultant and collaborator. In his words, the work of his practice stems from a vision for the role of engineering shaped by the humanistic rather than technical principles. Several important contemporary built projects from around India have Mr. Manjunath as a collaborating consultant and engineer. He's also a part of academia and the Wadiyar Center for Architecture, Mysore. He is closely involved with, where he continues to mentor young architects. Indeed, it's such an honor to welcome both Mr. Deepal and Mr. Manjunath to Design Conversation. We would like to request Mr. Deepal to please begin the presentation. Thank you.
Right. Thank you, Architect Varna and the team from Design United for inviting us from Sri Lanka to participate in this webinar today. And big thank you to all of you and good evening to all of you. If you look at this map of Sri Lanka, you will find the Bentotta, which is highlighted here. It is the boundary of the western province and the southern province. And it's bounded by a beautiful river called Bentotta River. And that's the place where the hotel is built, the place where it falls to the Indian Ocean. Now, talking about this area, in 1965, the government of Sri Lanka declared this as a tourism development zone, and legendary architect Jeffrey Bawa was assigned to do this famous hotel called Bentotta Beach Hotel. And if you look at the location, earlier I was told hundreds of years ago, this has been used by the Dutch administration as a natural fortification or sort of a with large undisturbed sand mound, which acts as a fortress. So in the design also, there are evidence to say that this has been there. So, I mean, without much elaboration, we'll get into the plan. I'll show you the original photographs taken in 1967. That is taken by Jeffrey Baba Associated. Now, if you see this aerial photograph, this is taken from the beach side. This was the hotel that was built in 67 to 69. And it had a character like a lower ground floor, which was connected with a ring of galleries. And also, what you see here, these protrusions were acting as bastions, like what you see in the photograph, stone bastion of the stone, and the stone bastions were connected with a ring of galleries right around. And that ring of gallery, that's the gallery that we're talking, was partly retaining the sand because created this upper platform. So this upper platform was supported by ring of retaining walls and also that acted as the galleries, and these bastions were also designed by the architect, the feature. So at the upper level, when you come to the hotel, you get down at the lower ground floor and climb up and get into the upper level, which is shown in this photograph. This is upper level. And the two levels above, which is sort of an L-shaped building that you see, photograph, were the residential facilities. And also, you can see this original plan. By the way, this plan is 50 odd years old. The two room blocks that was there, the single story room block, connected to the building. Right. Now, when architect Bava designed this hotel, at that time, imported materials were not much in use. So he used a lot of local materials, basically granite cut stone, polished concrete floor, and terracotta clay tile, dark timber paneling, are favorite materials that he has used. Now, I will show you another photograph of this hotel. I mentioned to you that the entrance was at the lower ground floor. The lower ground, what you see here is the entrance to the hotel, and you go through a staircase and go to the upper level, which was square in plan. And above that, these other two levels, it was an L block. So altogether, it had 4 levels. The lower ground floor, surrounded by this fortress, the ring of corridors and the upper stone wall. The upper level, which was the entrance pavilion, and from there, the guest rooms are on this upper, second and third level. What you see on the right hand side is a photograph, paint 3D sketch done by architect Bava's office in the late 1960s, which is slightly different from what we saw here, but what will show you what he has planned at a very early stage. And if you see the next photograph, I want to show you a drawing. This is again from old Jeffrey Baba office. As I told you, the ring of galleries that I was talking, going around the building, had a retaining wall. You can see these are stone retaining walls. Stone retaining wall, stone retaining wall, stone retaining wall. So basically that was supporting the sand that was here in this area. So that question that earlier mentioned about having a sand mound, that justification that something that is there, the way architect Bala has designed. The upper level, he had a nice, lovely water feature, and there were simple trees planted with a courtyard sunset. The upper level, and that building was the upper level was a square in plan, and above that we had 2 levels where the residential facilities were given to the guests. One important feature here is Baba had done this cantilever of a cantilever. If you can see, this is a cantilever and then it's another cantilever. So visually, it looks a cantilever of a cantilever. Even at the other drawing also, you can see that. But actually speaking, later only when we had studied the building, we found it was not so. He has done it in such a way visually, it shows, but actually it was suspended. So I'll explain to you in detail when it comes to that stage. Now, moving on, these are some of the old photographs of the building. Again, taken in the 60s. That same entrance that I showed you, the close-up. And actually, you can see some light there. That is the entrance steps that is going up to the public, what you call entrance lobby. You go down, you go, drop yourself at the lower ground level and climb up to the upper level, and from there to the guest area. Another view of the same building. You can see at a distance, you can see the stone walls, because it's the stone wall, and you can see this cantilever of a cantilever effect in all sides. That was a unique feature which is maintained in this building. Yes, we'll move on. This is another photograph of the old building. The single story block, the row block that I mentioned, this is the place that they had it here. And this is the main building again, what you see here. And this is another aerial photograph that takes to the river, is what you see here, and the Indian Ocean. And these are the old Gaul Colombo road with a rail line here. So these are all very nicely preserved photographs which we thought we'll share with you before it was developed. Right. Now, again, one of the last photographs I'm going to share with you, the old one. You can see this cantilever of a cantilever effect, but mind you, you can see these are all timber cladded concrete columns we had used. Timber cladded, very thin concrete columns. And it was basically what he has done is basically he has suspended, the cantilever, the slab here was basically held by these columns and taken to the upper level. It's beautifully done in a very creative way by, I think, at that time, the engineers who were fixing. And there was another plaque that was there, the original architect, Edward William Baker, Jeffrey Barr was a partner there, and the contractor was Hamid and Ahmed. And this is that entrance to the hotel that shows you that light. You see gate and there's a staircase going down. And see the quality of the stone wall that they have done. This is absolutely the concrete, the stone retaining wall, which is done by them that time, and the stone paving. Now, what happened in 2017, the present owners of the property were debating how to replace this hotel with a more appropriate structure that would cater for the current market trend, because this hotel had a limited number of rooms and the demands were quite high, and they had to do something to improve the number of rooms. So when the owners decided to retain the service of architect Chandadas Vassar, this young architect, he happened to work with Jeffrey Barr from 1991. He graduated from University of London in 1991 and joined Barr same year and worked in projects like Kandanama and Springbat Hotel and Lighthouse Hotel in Gaul. And in 11 years, he worked with Baba till he passed away in 2002, and all the remaining work too was handled by him. And he had clearly good understanding of the design philosophy that he used and do. So I think he was the best choice to do this hotel. That was the decision that the client owners were taken. So architect Daswatha always maintained that the main central building, that one that I showed you earlier, this main central building should be retained, always it should be retained, and it should be done, even if you do a connection, should be done in such a way without losing this original identity. So that was his argument. So whatever the connection, the new addition should be done in such a way that it should be also highlighted. It should be the most iconic portion of the complex. So then what happened? We were asked to do, if we are to redo this, if we are to, there are two things for that. Can you repair this building? Can you see structurally whether it is feasible to do the repairs. So we decided, let's do a structural survey and see whether the structural components were okay to be reused or what has been done. The fact that the structure was concealed because most of the structural columns was sold in the main building on the left-hand side, that's the main building, were cladded with solid timber panels. So when we removed, only we saw the fact that they have got cracked. Cracked in the sense, most of the columns have started cracking and the reinforcement has got exposed, and it was in a bit of a bad state, I would call it. That this particular building, this building on the left-hand side, the L building, that this building here was in a very bad state. So then after the report came, of course, anything can be repaired. The structural repair work would have led us to restoration of the old building after repairing and strengthening the structural members. The other thought was, if it is not the case, that we could rebuild the same building at the same location by reusing all the existing building materials that could be reused. Now, the second one was more challenging. The first one, okay, you repair the building, and there was one condition: we cannot change any of the original structural dimensions of the building. For example, if the column was 300 by 300, strengthening is one way we can strengthen it by increasing a ring of reinforcement outside with high strength concrete. We could have done that, but that was not allowed. We said, do not change the structural sizes of the existing building. So that we had to rule out. Then the only thing that we could have done was to prepare the track, see whether it is structurally stable. However, there was again arguments about what is the effectiveness of this repair and what kind of cost are we looking at. So after a couple of rounds of meetings, they decided, no, let's go for the second option. Let's rebuild the same building, the same location, by reusing whatever the material that could be reused. Because if you see the timber that they have used was absolutely in good shape, and even the granite stone, nothing has gone wrong. Because granite you can use for hundreds of years. So we had a good idea at that time that part of these things, like even though this building, this 3-story building was in bad shape, we found that the other single-story part of it was in a very good shape. However, we decided now to rebuild, so that means most of the areas has to be taken off. So then, through rebuilding, we had the exercise. The architect started measuring the existing building and also identifying each and every material that they have used, like numbered, photographed, and documented. So that was a quite tedious job. I will show you some of the things that they had done. Right, we can see, this was a stone pavement area. All the stones have been numbered, photographed, and documented. These are the famous staircase I mentioned at the beginning, the main entrance. You can see the timber staircase, all the risers and the treads marked, identified. And you can see this lovely copper handrail, it was protruding from a stone wall, which is again numbered and recorded. And this is a nice batik ceiling, the original batik ceiling done by one of the interior designers who worked with Baba calling Adisita. He's no longer with us. And that was the ceiling that they used at the entrance, the batik ceiling. That's very traditional Sri Lankan ceiling piece. So then measuring this was quite a tedious job. You can see even things like window mullions, window sashes, the ironmongery, and this is one of the balustrades, and even these are the thin concrete columns that is with timber, so nobody could have seen it. So all that was numbered and measured and photographed, documented. So when this work was over, as build drawings were done, there was another small issue at that time. We found grid-to-grid measurements. Now, always we are engineers, architects, maintain certain accuracy. To find that, we found certain grids were off by a couple of inches, like 4 to 5 inches, and some were less, some were more. So the next question is, we can redo the new structure as per the very accurately on grid to grid to maintain the same distance. But if we had to refix these some of these values later and doing the frame, then we have to do alteration. Then they said, no, don't do any alteration. Let's build as per those. Even with the errors, let's go with that. So we decided we will not change errors that taken place 50 years ago. We'll go with that. Then, once the green light was given for reconstruction, we as structural engineers examined the building again. And as I mentioned to you earlier, this entrance area, the retaining wall, and the stone, the galleries that we had, these structures were in very sound condition. No leaks, no cracks. So then we said, if that is the case, the stone wall can be just leave it before without removing. Then came two concrete elements we found. Now, if you see this photograph, you'll be amazed. This is that entrance spot that I mentioned. You come here, and this is that entrance area. And this is a concrete slab where Baba has pasted granite to the soffit of it. I mean, this is such a beautiful piece of work. And the funny thing is, there were no leaks, no dampness, no cracks. So then, still the owners are a bit concerned, okay, still whether it is okay to reuse without doing any changes. And but this is the staircase that was going up to the main entrance. And this is that stone that gallery I was talking. And this particular slab, we decided in that case, we will take a small core sample, 2 or 3 core samples per taken and test it. And the results were absolutely good. We had very good results of the concrete testing. And I can share that result. You can see we had something like 27 newtons per millimeter square compressive strength of the concrete. And also the core sample that we took, I took 2 photographs, see the particle distribution. The aggregate distribution is so even. There is no segregation that has taken place. Very well placed. The aggregate has been very well placed and uniform placed, and that means very good vibration. The vibration has taken place during concreting, and we then concluded this should not be touched. Let us keep it. And I mentioned to you, there were another component that interested us. What you see in your right hand side is a circular staircase with a center column. This is the feature that they maintain in 3 places of the building. I'll show you this one through the plans again. They had a staircase here, and a staircase here. All have this feature with a single pillar at the center, and the staircase was like, from the column, it was radiating towards the core wall. And I'll show you the staircase. Now you can see the single pillar, and this is the staircase core wall, and it was a circular staircase going, it wrapped around the column. And these are the handrails that they use. You can see they have numbered again, but these are reused. So this concrete structure here also we found strength was within our building. Right now, the reason, other thing you can see, if you see the soffit of this staircase, I mean, it is basically a very narrow strip effect finish, which they have done. I was later told we never had plywood shuttering at that time. What they had done is they have used a timber called American tree timber. American tree is very flexible, very fragile. You can cut a small strip. He has done the shuttering with these American tree strips and put the reinforcement up and completed. and removed the shuttering and found that impregnation of these tree trunks have come into this effect. I think it is not a uniform finish also. He would have used the concept, the Japanese concept called wabi-sabi concept, where you don't finish building to a perfection. It is finished to a near imperfection. So I feel that he has used this theory. That's why you can see it's irregular, but it has a character. So having this feature and being the strength of the concrete also okay, we told the client, please leave these 3 cores on the staircase and the entrance board, and the rest we started demolishing. Now start the work. We have started, okay, now the demolition work started commencing, and it was such a tedious job because a lot of concrete portions that we taken off. Mind you, I must tell you that all demolished concrete was reused in a crushing plant in Sri Lanka, which was used again for making concrete, and also used for sand and for road subbases. So anyway, the structure started getting demolished one by one. And what you see here is the staircase core that we said we will retain. And this is that 3-story building with cantilever effect is still empty. And the structure partly got demolished, and the foundations were taken off. This is another staircase core wall that was retained, and the structure got demolished. Now, I'm showing you the 3rd level of the building. Now, all the plans are redrawn. 3rd level, this is what it was. You get the room block, you get a room, very small, sort of small room they had at the location. The architect that's what the proposed, that he will make 2 rooms into 1. That means he is taking off this wall internally, but outside there was a small partition wall out of terracotta tiles. As I can show you again that one. Right. These are the terracotta wall partitions we had, right? That retained in all levels, but internal wall, that particular wall was taken and he made it to a double row, or what is called a suite. So right. Now this was the standard rooming he had, and looking at the right hand, you can see the structural section that was there, that was earlier which they have done. The main columns, these are the ones that was badly deteriorated, so we removed them. And externally, we had a corridor, which is single story, and he had a concrete beam and a slab protruding out. What he has done there, and that is basically a 1.5 meter protrusion, looks like a cantilever, but he had a column. He had a very thin column, 125 millimeters, 5 by 5 column, and that column was actually suspending this slab here, and that basically the slab was hung by this column, and it is taken to a beam here. At the upper level, he had a huge upstand beam at this point, where the big walls. So basically, this particular slab was supported on one side with long beam, not going to be here, and the 2 columns, these 2 columns are holding the slab, and it was like a flat slab at that time, a flat slab, so put on 2 columns, but inverted, and the column was subject to tension, and that load was transferred to the upstand beam at the 3rd level, and that is here. And here we had this further cantilever here. Now what he has done is, now this is because upstand beam underneath you can't see, and this is the partition wall that he had, the terracotta partition wall. And now at the 3rd level, this slab was protruding. Again, he has used 160 millimeter thick, small thin slab, and there was another floating column which he has taken the load of it. Again, that column was basically this part of the slab was like a flat slab with inverted flat slab with 2 columns supporting the slab, and hung from this concrete portal frame at the top. The concrete waterfront quite a solid one here design. If I show you, this is, can you see these are the original concrete water frames we have, because these are the column that we are talking about, hanging columns. That is how we have the column from the water frame, and the slab was taken. The slab load was taken partly to that. So underneath, you don't see it. You look, it's like sort of a screen topic. Then, with this new proposal of the architect, we were told that we can't have upstand beam here. I mean, it's quite natural, you can't have an upstand beam in the middle of the room. So, and they said you can't change the structural characteristics also. And it was a bit of a jigsaw puzzle. Then we asked, in that case, can we have a beam? Now, this is a new proposal that we said, can we have a downstand beam? Because they had a ceiling also. They said, yes, but can't take it out like last time. Last time they had taken the upstand beam out. They said, no, you can't take it out. Now, with this limitation, now for 3 meters cantilevering, that and of course 3 meters cantilevering with this thin column, but that was not possible. This was a reflection. Then we asked, okay, if that's the case, this particular column that was stopped at the lower level, we said, can we take it through the same 125 column, and we can suspend it. The column, the step could be suspended with the help of these two columns, this column and this one, and the long beam connecting the columns. So at that stage, we found, okay, this portal frame was quite strong and quite a solid portal frame, and we designed this particular slab in such a way that we had two columns that are originally there, and these columns also. So it is suspended of 4 points, and partially, and there is a beam. This particular beam was running lengthwise, also supporting the slab. At that way, we said, all right, then this structurally works, because we couldn't change any of the slab thicknesses, change the size of the column. Only thing they allowed was, instead of the upstand beam here, they said we can have a downstand. The ideal thing was, if we had this protrusion here, then I think that's gone. But they insisted they can't give you a downstand beam. So with this arrangement, we said, all right, we'll start construction. Then we did the lower foundation part and the ground slab. Then came the existing column sizes were maintained, 300 by 450. Then came the 160 original slab with the small to support the roof. Then came the next level of column to the hanging column. Then the third level, 160 millimeter again, that's done with a new downstand beam. That's the only change we did. Visually, without the ceiling, so that they can see changes from outside. Then raise the columns to the top level. Then did the portal frame, and the roof came up. The fact that none of these things were propped and till the whole structure was completed, till the load came, we did not want to remove any of these props, because finally the load was transferred. It was hung. This column was hung here, so the load will be transferred to the portal frame at last. So till the whole thing was finished, we didn't remove any of the propping arrangement that was done. Then I can show you some of the photographs during construction. This is a new building that was constructed. You can see the thin slab and the thin column. Looks a bit scary, but structurally it was quite stable. And finally, this is the construction stage. And finally, these again construction stage photographs. And finally, this is completed. Now, these are completed buildings. This is finally the reconstructed building, all timber doors and the existing one. All these timber balustrade, timber cladded columns, everything what that was used earlier. The terracotta tiles and the partitions, of course, they were new, but same sections were used. And we had to use new tiles here. And that was the completed building after the reconstruction, or what we call it as a concert. And this is a photograph taken from the southern beach side of the building, the same portresses, staircases, the lower ground level, and the two upper levels. And that is the building that we finished. And I must show you the original ceiling that was used. This is a photograph taken in the 60s. You can see the black and white photograph with the hotel staff with the public ceiling, and this is during the 80s they had taken, and this is finally after the responsible to this over the new ceiling done by the same party, and the same party ceiling was done, reproduced. That covers the building for the building that we did. Now I want to just show you the main project that we did. This is the old building that was reproduced the same way, and that's what added the banquet hall here, and the room blocks coming here, and the room blocks in the back of house. So it's quite a large hotel because earlier it was only small, but 150 room hotel. Also, I must tell you, he did one interesting building. You can see some line here. It's the restaurant, specialty restaurant, and the all-day dining, all that was the house here. It's a single-story concrete structure with a folded concrete plate at the top and landscape at the top in such a way that you don't see any of the concrete from this building. So that was his intention. And he also, like Baba pasted stones at the soffit of the entrance porch, he decided he also want to do something unique, and he asked us whether we could have the impregnation of a coconut palm to the soffit of the slab. So we said, all right. We found dead coconut palm, placed it in the bottom of the shuttering, and placed the reinforcement concreted. And when removing the shuttering, the dead leaves also removed, and finally gave this kind of feature. And it was quite a nice soffit. It just is a raw concrete, and finally he just polished it and made it. And this is part of that building. I thought I'd highlight that part of the building also for you. And with that, we will conclude. Thank you.
Thank you, Mr. Deepal, for your fascinating presentation, for sharing the challenges that came with the renovation of this project during restoration, and also for sharing your thoughts and work. Appreciated greatly.
Thank you.
Thank you. With this, we would like to invite Mr. Manjunath to kindly share his presentation. Thank you.
Good evening to everybody. Hope you can hear me.
Yeah, we can hear you.
Yeah. Good evening, Deepal.
Good evening.
And the whole DU team. I'm just basically, I'm just have some few questions, very, very basic questions, which I want to share as part of this discussion. And as a part of these questions, my exploration, my way of exploring things with material through my own projects, I will show it to you. But it's still nothing satisfying to me right now, but still curious with more questions, So I'm just going to very, very basic, like when I heard one of the statement by a physicist that, gravity is the hidden geometry of space, how does gravity has become part of our life? We don't see it, but somehow we have gone through it. So I'll show you the next slide. Is very simple, like say like how does these things which impact us, like the sun, the gravity, and the wind, so many things which is happening above the ground, which has an impact on what we build. So how do I know before I build what are these forces? Then if I go to the second slide, the next slide, it basically gives you, like as a human, as the moment you are born, somehow you are comforted by gravity, but somehow you are moving against gravity, in the sense that the marriage with gravity and life, is basically a balance of stability, So somewhere you see, you are feeling tension, since you are going against gravity, you feel what is that tension, tension going against it, and then started balancing it. Then as you end your life, you are comforted by gravity. You finally go back to the mother earth. This is bit, it is part of you. Gravity is part of you. So why our aspiration is anti-gravity, but somehow we forget that what is gravity, has an inbuilt feeling with you. How why we are forgetting it. Yeah. So the next is yeah, same thing. Like when I look at structures above the ground, it's so nice that there is a texture. There is some sort of a texture which I can feel. Like you have a concentration towards the ground, and then you have fragmentation as it goes up to the sky. So that the principle here is the sun rays has to come to the ground. The perforation makes the sun rays to come to the ground. So how there is a marriage between the sun and the land. How elements in nature you know understands this and then perform accordingly. But humans, we don't even recognize these relations, which is actually inbuilt as a system. So it's a bit understand. And I'm also very curious about the coconut tree. To me, is the position of the coconut tree is is at the transition between water and land. So the first set of forces will come to the coconut tree, but still it is quite stable. So what is this coconut tree made up of? What is this sequence of shedding the leaves has related to forming a concentration of fibers which somehow replicates a spring? Is it a concentration? Is it a combination of concentric springs? I don't know. It's just a series of seamless questions which provokes me to know more. That is what is. And there's no failure in a coconut tree. So, and what are these coconuts in a coconut tree? So these are to me is counterweights which balances the swing. Is this the one which is adopted in tall buildings where they use a pendulum for earthquakes? Is it that? Is this the analogy? I don't know. There's a lot of things which actually teach us through observation. So which is actually, all these things are beyond you. The scale of you on this earth, but your thought process is spread between you and the land and the universe. So this has been the past, when where people started measuring, not through calculators, but the use of the the whole solar system. So why no, this is a bit curious to me. Next slide. Yeah. So I think with this, I was just looking at the skeleton. What could be the skeleton of a tree, or the skeleton of any living things? So I thought, there could be a spiral. There could be a spiral which is constant, which is moving around the periphery, which are strutted by series of elements, which basically, controls this slenderness, and then this whole, struts are, basically transferring the force to a skin outside through hoop tension, then you see a skin. This concentration, it's like a star to me. It's like, no, what you see on plan doesn't show as in cross section. So to me is like, this can be a cross section of an energy, or it can be it can be a continuous seamless force. So what became curious to me is, the beauty about seamlessness. There is no abrupt ending. It is continuous. It basically, it's like very poetic, very poetic. It grips you. It takes you through, So I think this visual ability, to somehow see seamless in nature is a bit curious to me now, seeing like layering is seamlessness, layering is fantastic. You have different layers which are moving independently, to perform different duties. Okay, at certain point it may be concentrated for a particular duty, but it may go and then do some other duty. So this layering of seamlessness, is something which is very, which is part of my thought process and part of my job. So next slide. Yeah. And I'm also curious to look at geology, the 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 the, the formation of the rocks. When I look at the rock, I'm not curious why this shape. What are the forces which made this rock like that? So your question is on the unseen, okay, which basically draws the inspiration from the scene. These are the duality which makes you, more curious to understand. So next slide. Next slide is about, is about the seamlessness of erosion. So when I'm looking at materials where there is a fluidity at one time, or the air which is cutting the sand, the wind, the water, so I'm a bit curious to look at uh, things which you don't see, through the effect of it. Yeah. Next slide. So these are some of the things which are, like, you see a mountain. When you see a mountain, you see how it ages, okay, and then how the profile of the mountain has a relation to water, okay. So the mountain is projected to give a head to the water. That is how the water is moving towards, through the head and the erosion, and that is the reference of what you see. Next. And by looking at these animals, you look at this massive, see how it is positioned. These are like, you have a counterweight, but you have a two ends of the counterweight. Is managed by these two, long cantilevers. Like, but these are vegetarian. These are, grass eating. But see how the whole cross section, the skeleton of this structure is fantastic. Why we can't draw inspiration and build buildings? These are dynamic. These are moving structures. So why we can't do a stable structure out of these as inspiration? Because all these are available in nature, free of cost. Next. So so for me is, See, finally, as an engineer, we are taught only three equations. That is sigma h is equal to 0, sigma v is equal to 0, sigma m is equal to 0. So how does you have these structures where the forces finally end up into the ground very safely. So to make that, you need to have a seamless thought process of force transfer. Yeah. Next. Yeah. So at these are say when I look at this building, uh, when you look at the idea behind it, it is so simple. In India, where in melas and all, where they spread and put some counterweight. So here the building itself is a counterweight. You stretch a fabric. So why these simple ideas can't be explored? These are these. I think the beauty about looking at things. I think distilling what you see through free body diagrams will probably help you to understand it much better rather than looking at visually without drawing into the depth of decifying it. Like yeah. Next. So this is yeah. So nobody understand that the buildings are the counterweight. Yeah. Next. And this is also very curious to me. Is like when you look at these two sketches, these two sketches are very interesting to me. Is like when you build a building on a hill, okay, so you build a hill, so there is no horizontality, you can't build. So how do you create a building which is anchored normal into the rock or the soil or the slope? Okay, how do you induce more compression by pulling it. So when you look at the building, where you have a better view, okay, you have tension members. So you are pulling it. So it's not so people get confused that you are strutting it, so that what happens to slenderness? No, there is no compression at all. So you are pulling it to confine it. Similarly, I reverse this whole thing mechanism on a horizontal plane and create a bow. Okay, so this is done. This same an architect, Hazog Demerlong, for one of his stadiums, where he created a bowl as a stadium, support system, where he confined, he held this whole bowl into the ground by pulling it down at the free end. So when you look at the structure, the fragmentation of the periphery makes the structure very light. And most of the people get confused that how come these columns are so thin and you design buildings with thick columns? This is basically columns in tension. There is no slenderness, so you have to pull it to come, confine it. Okay, so these are very interesting structural thought process which can be adopted for different. Yeah. Next. So this is what very interestingly, this is an image of very interesting. It's just this is small museums, zinc museum, which is done by Peter Zumthor. Very carefully this position of this building. You see these buildings are diagonal, slightly located in the direction of the slope. Okay, very, very carefully has positioned it in such a way that the maximum number of columns will come at the upstream, whereas very less number of columns predominantly are tension members, okay, which are the upstream end. So, but these are like it's like I think it's structurally inspired. The residue is more structural. Next. So this with curiosity, with this as the curiosity, I will show you some of my exploration, which is still work in progress. I'm just trying out this logic of a concentration towards the ground, a fragmentations towards the sky, and then you also look at a surface. Surface is somehow a relation of compression and linearity. Linearity can also become more of fragmentation. So with this, how do I go from a density there? Gravity was part of it. So when I look at lighter elements, in gravity doesn't play a big role, but stiffness play a major role. So with lighter elements, you have to look at the stiffer profile, stiffer arrangement of elements, and which is right now the future, in the sense that because we have different materials, we have already changing materials from CFT to square foot, like stone right now is being measured as more as SFT rather than CFT. So that clearly shows that somewhere on the line we have moved from higher denser materials towards gravity to lighter materials against gravity. Okay, so these are structures which are very light, more stiff. Okay, so let me go to the next slide. So as a philosophy of our office is basically, look at just go back, just go into the seed of the system, in the sense we're not fascinated by, how it looks right now, in the beginning, just identify the seed of the system so that, you need to comfort it for the building to grow. And second thing is about materials, like how do I potential of this material, till the failure, in terms of in terms of its strength, in terms of texture, in terms of, the ability to take, torsion, so we go through this exercise and deriving simplicity in structure through free body diagrams, like a practice of removing things what is not required. You start removing things what is not required, finally, just to find the within, and learning from nature and layering. Layering forces, rather than, there, to me is like bending is man-made, working with pure force is more. Since is about seamlessness of thought process. So I thought, why not be layering elements, working with unstable elements to make it stable. A combination of unstable elements becomes stable once you combine it intelligently. So steel weaving is more like weaving steel mentally. That is what I was looking at. So this was a small exercise about 5-6 years back, just trying, how, like a kid, how aluminum and how wood can combine, what is the friction, what is the locking system, can we do furniture with this, can we do, building out of it, So, the whole element is suspended. How do you look at structures which are suspended and look at if I look at a tree, the tree has a concentration towards the ground and fragmentation as it goes higher with leaves, and then a lot of animals stay in that. So why can't I do a building where station can be replicated as portals? So I did 3 portals in concrete, which basically are spaced in such a way that it is stable without bracing, and the profiles are done in such a way that it was independently stable. And then we suspended 2 floors from the bottom and then had 2 floors on the top. So this medium of heaviness, which was anchored into the ground, held 2 types of structure. One is 2 floors of suspension. So when you do members in tension, it becomes so light that it becomes like more like a Latin where you see, if I show you. So this is basically the 3 portals, what you see, okay? And then you see the structure which is suspended so light, because the spacing is about 12 meters. It's 12 meters, and it's a very small site, which is about 5 by 45. So we have to create this so that, you can park the cars below and then accommodate to light suspended floors, and then you created 2 more floors, because that 2 floors are the offices for him. Yeah. So I'll show the next slide, which basically this is a completed building. Okay, you see 2 floors of office space and 2 floors of suspension, but the core, the anchor or the concentration is the portals. So the tree becomes a cantilever structure. Here it is, it's a bit a stable structure which allows these 2 elements to become spaces. Yeah, next. So these are, so we as engineers, we started getting into more trying out something where you can suspend the whole staircase. So it's just just to learn more. Yeah, next. Yeah, next. See, if you go back here in this, see, you see the color, where the car parking, you don't have any major elements. Everything is suspended. The moment you see the structure, it looks so light for a span of 12 meters because it's all suspended. Suspension becomes part of the, partition wall system. Yeah. So this is another structure which is also an outcome of the same thought process. A human being or a series of humans who are going to walk on the hill. So it's all about balancing. How do you put the first leg and then balance the rear leg so that you can shift it and then manage the center of gravity. The whole point in a hill is to manage the center of gravity so that you don't topple, you know. So we also tried a same concept through steel weaving, wherein we created two directional supports, which basically created a twist. A twist basically always make it stronger, you know. I don't know, like in India, what they say is if somebody is slightly weak in mathematics, so the usual way is to twist the ear, you know, so that the brain start working, you know. So, you know, these are, you know, this is just a, you know, this is, it's like you twist any material, okay, suddenly it creates a stiffness which helps us. A repeated stiffness becomes more stronger. So this whole structure is built with elements which are doing different things at a different point of time. So there is no redundancy in the structure. Yeah, next. So these are no welding at all. So everything is bolted, and every overlaps are worked out. It has vibration. Once it is fully finished, the building becomes rigid. So it is more like it a plant or a human being. You can you can talk to this building. You know, this building has, to me, is life. You know, I can talk to these buildings. And what we create through buildings. Yeah, next. So these are some details which we so this is a small how it developed, you know, what is a spring, what is, you know, how does this connect, you know, is some sort of an architectural uh, inspiration about that. Yeah, yeah. These are some few images of this building. This is about 5 year, I think. Yeah, it's about 4 5 years old. So it's a retreat in Coorg, not Coorg, sorry, Kuno. It's in Uti. Yeah, these are some photos. So this, yeah, this is another building which is very same language. This is also very same language wherein you know, which also goes through steering. This is an architecture school in Mysore. This is also built on the same system with zero redundancy. Yeah, you can show some of the slides here. Yeah, yeah. I'm going a bit fast, so yeah, yeah. Next, next, next. So these are some of the images in this, of the school. Next. Next. So this is also one of the building which we have recently finished for a restaurant in Whitefield, which wherein we played with you know, simple angles to create channels. You know, you create different elements because each element is a layer, but it is as a combination. It has a particular, you know, cross section to take the particular force. So we build these sections and then accordingly worked out the detail. You know, yeah. Next. These are a few images of this building. You know, this building is almost over. Yeah, next few. Yeah, this is very similar to what you know, Deepal talked about. Is about how do you make a structure with capital support at the top and then suspend the whole building. So this whole building is about a core. This whole building is about a core, and then the whole floor plates are suspended. So next slide. If you look at this is a mushroom support. You have a lift and a staircase, which is RCC core. Then the whole spread of the whole floor plate is suspended from the top. So you have a capital truss on the top, and then we managed to balance all the forces through bracing and then tension elements. Yeah, this is an apartment building which is finished. This is for a developer. This is in Cunningham Road. Yeah, next. Yeah, this is a project in Kochi. This is for the Kochi Binale, where we tried with it's like a flower. Like you look at a diagonal rigidity what you create, an element which can it is like more like strutting. You compress it at the counterweight where there's a lift, so it's about the material ability. So the seamlessness of the material can be managed by applying a compression or pulling it down. By the profiles you create a form. So this is just one of the this one. So you can look at the whole structure. It's a quite large structure. The whole the inside is filled with bamboo. Otherwise, it's totally a transparent structure. Yeah, this structure was built only for 3 months at a very, very low budget, and so we had to do it through a structural concept. Yeah. Next. Yeah. That's the next. Thank you.
Thank you so much, Mr. Manjunath, for this very interesting presentation that has looked at architecture as structures while sharing your ideas and your philosophy towards your practice. It's been really enriching. I would like to thank both engineers, Mr. Deepal and Mr. Manjunath, for their wonderful presentations. With this, we invite the audience to please share your questions for our presenters. I would also like to take this opportunity to welcome and introduce our moderating architects this evening. Architect Vaishnavi Shukla joining us from Ahmedabad. Vaishnavi has an undergraduate degree in architecture from CEPT University and a master's degree in design studies from GST Harvard, where her master's thesis focused on the architectural manifestation of national identity through state-sponsored projects. She has also co-chaired Women in Design GST, which looked at advancing gender equity. Vaishnavi has a connection with Sri Lanka as she interned with Palanda Kannangara architects there. Shreyas Yohan is another young architect from Kochi who's joining us from Mumbai today. He has a bachelor's degree from RVCE Bangalore. He's currently a project architect at Rahul Mehrotra Associates Mumbai and is their project architect. His interest lies in theory and construction. It's a delight to welcome both Shreyas and Vaishnavi to Design Conversation. With this, we request the audience to please share their questions for our esteemed speakers. Thank you.
Thank you, Wagner, for that introduction, and thank you to the speakers for the wonderful and insightful presentation. I'm going to dig right in and ask the first question to Mr. Deepal. As I'd mentioned previously before through our email correspondence as well, it's fascinating to learn the breadth of the undertaking that took place to rebuild the Bentota Beach Resort. You mentioned in your presentation that parts of the original resort were retained as they were structurally sound, while the rest were reconstructed. What were the challenges of integrating push you perhaps alter the original design in order to maintain the structural integrity of the final output?
Thank you for that question, Shaz. Basically, as I told you, we tested the concrete and found the existing concrete structure had a strength of between 25 to 30 newtons per millimeter square. And our new structures also, we designed for that grade of concrete. So if there was this issue would have come if we had to go for high stress concrete new structure, then the connection would have been different because the existing concrete strength was less or about 25 to 30% less than what we have planned. But here, in this case, it was the same strength. So there was no major design variation or revision that we had to do, because concrete structures that we designed also had the intended strength was equal to what they had used earlier.
Okay, thank you. Over to you, Vaishnavi.
Thank you so much for two very wonderful presentations. It's been, I think, just a pleasure to see both the Bentota Beach Hotel and both the Kochi Pavilion especially. I think I've only seen it in pictures, so to see you talk about it, Mr. Manjunath, has been very insightful. So my question to you is, it's very interesting to see you talk about nature as a source of inspiration. You know, when you talk about the natural phenomena and the cause and effect relationship between various natural elements. So this is definitely the most essential way in which we architects are introduced to the fundamentals of structure, you know, in architecture school, second year, first year, when we have introduction to structures. However, somewhere along the way, we as architects tend to lose that sense of connection to the simple laws of nature. And we tend to get overwhelmed by the form making, and nowadays architectural softwares make it increasingly possible to envision forms that are far away from the natural principles that you just talked about. So in your opinion, what is a design philosophy that can keep architects grounded? Or in other words, how can young architects still draw inspiration from the environment and evolve their practices that are connected to the basics of nature?
I think see, I'm from the old school, basically. So most of the time, we were on the fields rather than from the, than in the class. So we used to play with mud. We used to climb trees. So we had this hobby to play with nature. So somehow today's kids, I think they have lost to observe. We need to observe. We need to, like how many people held one brick in their hand? Architects. What I'm saying. Forget about architects, even engineers. What is the texture of the brick? What is the density of the brick? Okay, and what is this brick made up of? Can you smell the brick? Can you taste the brick? Can you sit on the brick? This relation is missing. This relation is so important that it's not about drawing surfaces through computer without even touching the material. Doesn't have any meaning. So I think you need to learn to play. You need to learn to play, use the material, and then your hands have to be part of this. So I think it's about loosening out, to know more about nature and things around you is what is more important, rather than looking at the future and then looking at tectonics, looking at softwares which are so virtual can create anything. So it's all basically comes down to mathematics. This whole thing is about mathematics. It's not about creating through computers. So it's just a tool. So I still you have to go back to your roots, basically, just to enjoy what you are doing. If you are I think we play with all the materials which are available in nature, like stone, wood, everything. Yeah.
So back to the basics is what we all need to do.
Yeah. Huh? As part of the ground, you have to feel the ground. Hope this clears your doubt.
Shreyas, you're on mute.
Yeah.
Yeah.
Mr. Manjunath, this is a question again for you. There's a trend to create simple and streamlined architecture, visually free from complex workings of the internal structure and services of the building. It's quite the contrary in many of your projects, where the structure is the main protagonist or it takes a front stage of the spectacle, and I mean that in the best way possible. As an author of the design process, can you tell us a little bit about your role in driving the overall architect? Or in other words, what is your collaborative relationship with the architect like?
I couldn't get the last line.
Basically, what is your what is your collaborative relationship, the synergy between the architect and you?
Yeah,
how is that process like?
Yeah, I think I think I'm touchwood. I'm very, the architects who come to me basically involve me at the very initial stage, so they basically brief the first meeting with the client to me, in the sense that, so I have got a job and this is what I feel about it. What do you think? Okay, so that liberty, that that respect, which we know, that honest, that honesty, is somehow which, which helps me to, look at things in my own way. This is what is, I think, to me, is a great collaboration. So I come out with what I feel, but I'll give about 10 options or 12 options, but he has to choose from that. I think this is I think we go with the same energy.
Yeah,
I think we are part of the whole system. So it's not that who is going to do more work is not the point here. How do we keep this energy constant, is what is more important to us, and it's a fantastic marriage so far.
So in a nutshell,
there are fights. There's nothing, so there are difficulties, but but at the end of the day, the product is very fulfilling.
Right. So in a nutshell, you mean that you're there from the beginning, from concept.
Yeah, from the beginning. From the beginning.
Yeah. Okay. Yeah. Over to you, Vaishnavi.
So speaking of, I think, teamwork and collaboration, Mr. Deepal, you mentioned that there were two schools of thought at the beginning of the project. First, that advocated for restoration of the existing building, and the second that argued for reconstruction. And the team eventually decided on reconstruction, and the process folded accordingly. I'm curious to know what your role and the subsequent process would have looked like had you adopted the first option of complete restoration instead of rebuilding.
The second option was more challenging, right? But if the first option was taken, it's like serious by the client. The restoration means basically we are structurally redoing the affected areas and repairing the building. And it has been a much smaller magnitude of project then. And only thing is our work would have been quite limited there. But in the second option, we had a major role to play. Study the existing material, what can be retained, and how the structure had been designed earlier. All that has been studied in the second option. So I think work-wise, that was more challenging for us. And also coming out with the architect's proposal, as I told you, they did a small revision at the top level, which had a major structural implication for us as engineers, and how we sorted out without changing the what you call the external finishes of the building. Structurally, externally it remained the same. We managed to do the modification without getting it highlighted externally. So there were quite challenges, and they were basically good challenges, I would say. And that is, personally, I think I enjoyed this second revision, that second suggestion of the client.
Okay, Mr. Deepal, I'm taking basically a wider stance here. Considering the capitalistic world we're living in right now, with the looming threat of environmental degradation and the planet littered with monofunctional and basically single-use buildings, in your opinion, would you say projects of restore conservation and adaptive reuse like the Bentota Beach Resort have gained increased relevance right now, as opposed to constructing from scratch?
Yes, I think this is the first time that we did this type of thing in Sri Lanka, but I think it's a trendsetter now because, as you say, the environmental pollution in the new building construction, every time you start a new building, there's pollution and material wastage. So I think this is a good starting point to look at how we can minimize also reuse what has been used earlier. And I think that's a good start. This should be followed.
Yeah.
The same Mother Earth.
Yeah. Yeah. Makes sense. Yeah. Thank you.
So I'm going to shift gears a little bit before we take the audience questions. But Mr. Manjunath, you very briefly showed us a slide with pictures of a joinery. And it seemed like the model was made to test that particular junction detail. I personally found it very intriguing to see model making as a part of your structural design process, especially since model making seems to have been reserved, only for architects. Can you tell us a little bit about the role of model making in your design process?
So, yeah. So what we have done as a philosophy very recently, about 3-4 years back, what we have started is we are inviting architects to be part of the team in the office. So there are architects who are willing to learn engineering. So I work closely with the architects in the office, where we start discussing the whole thing about before the materiality of the whole the structure. We start working with simple junctions for force transfer. Say if I am looking at bamboo, okay, how do I see most of the materials what you see in nature are doesn't have any end conditions. It comes out from the root and then goes out as a free end. So how do I use these natural elements as an element of transferring force? So we try and then make these junctions by ourselves and then try out either we apply force or we twist, we shear, we just understand how the material is performing. So like if you look at wood joints, for that matter, wood joints are like we are doing a building with stone right now, wherein the whole building is held only through gravity. So we size up the members in such a way that the gravity takes over. So only locking, we work out intricate locking between the stone to stone junctions, so that the movement is minimized to a great extent. So I think I think to me it's about trying out and then seeing how best we can. I think it's more of craft rather than engineering when you look at materials. When you understand from the material, it actually somehow gives you clues for junctions. I think it's more like a craft. Yeah.
Yeah, that's definitely a very different approach from trying it all in software. So I think it's a whole philosophy where you're directly working with materials and you understand the rules and the essentials by actually doing it rather than computing it. I mean, as a predominant process. So thank you so much for sharing that with us. Mr. Deepal, we have an audience question, and I'm going to promote this question because I'm a huge fan myself. So during the time that I lived in Sri Lanka, I had the opportunity to go visit the Lunukanga estate, and Palinda sir took us to the house at 33rd Lane and the gallery cafe and everything. So what was your experience like working with Jeffrey Bawa? Plain and simple.
When I first met Jeffrey in 1989 at a very informal discussion, Because, I worked with an architect called Anjalendran, I think Varna will know, she worked with him. And I managed to do this SOS Children's Village goal. In the early 80s, I used concrete rafters. So architect Baba has been secretly asking what is the steel he has used inside the section for the concrete rafters to make it so thin. So, Anjalendran is the one who gave an introduction to Baba. And my first experience was we did a small renovation project at Singbad Hotel in Kalutara, I can remember. And the next one was a big hit, the Sandanaha. Then he asked me to again redo the Singbad now, which is called Anantara, and was involved in Lighthouse Hotel. So I had about 10 years experience working with him. And that architect Bang was an engineer himself, right? And he knew exactly what he was asking for. Sometimes he asked, as I mentioned at the beginning, he asked really impossible things, but he knows it can be done also. So I think that's a very good relationship I had with Baba for about 7 years. He died. I had about 3-4 projects with him. And also in the process, Handanam was a very good experience, but let's talk about that project separately some other day. How he looked at it, how he handled it, and especially at the entrance, what he did. It's amazing. So I think now after doing Handanam, he did Singbad, totally different approach. That's a difference that man. He never looked at previous project when he was designing this one. So that was a difference in the person.
Yeah, thank you so much for sharing, because I feel like now we are all realizing that we are in presence of, you being the legendary structural engineer, because even with Anjalendra, in Ahmedabad, at least in west of India, there's so much of fanfare regarding both Baba and Anjalendra, and both the books are kind of present everywhere you go. So thank you so much for sharing your experience. Just to be mindful of the time, I'm going to hand it over to Shreyas to ask one last question before we wrap it up.
This question is for both of you. There is an inherent quality to your work that is rooted in the craft of building construction and its tectonics, while remaining sensitive to the overall aesthetic vision of structure is also reflected in your presentations as well. Can you give us a glimpse back to an early memory that triggered your interest in the structure and aesthetics of things, which subsequently forged your paths as structural engineers or designers?
I think Manjunath should start. Your experience, I follow it.
Okay, so to me is I think it's a journey. It's a journey for me, in the sense like 15-20 years of journey of working with the structure where architects started. I read this. I'll just basically tell you, when I read this book by Peter Rice called Unseen Hand. There's a book, fantastic book written by Peter Rice. It says engineers imagines, okay, or it is unseen hand. So most of the engineers are basically not to be seen. You are well within the structure. You are basically taking all the strain of all the architect's creation. Okay, so then then I started how can an engineer or an architect can reverse their role to become a creator. So as education, as part of the education, you are named with traits. Okay, that you are a service consultant, so after some time you are evolved to become a creator. That is when you start thinking about engineering, which is also an architecture, you know. And engineering can also become an architecture. You know, it can be beautiful. You know, you can look at proportions, you can fragment it into elements where it is appealing. So this boundary which was there as part of your education started blurring the moment I started uneducating myself. You need to uneducate. You have to shed education to start creating. This is part of my evolving process. So this is still continuing. I don't know from where. So in a nutshell, this is what it's all about. There is a very thin line between engineering and architecture, if I have to tell you. It is a very, very thin line. Yeah, Deepal.
Well,
you have to, this. Yeah.
good. I mean, quite a philosophical approach there, I think. Mine, I must say, as a student long years ago, I used to draw each and every house that I see or a building I see. I used to draw everything. And eventually what happened every day, now I can pick up something on the way. What I see, I draw. And the road to my school had a number of houses, and I used to draw it. And I could remember if I miss out something, the following day I can see it. I used to draw all that and wonder how these things have been built. I'm talking a very small child. But mind you, this Bensuda Beach Hotel, and this is something that nobody knows, but in the 70s, when we used to go to Colombo from Goa, I used to see this building. I was amazed to find that the cantilever of a cantilever, that building, which is actually not the one, but visually, that building was something that really inspired as a student even. I never knew that finally I'll get the chance of redoing that after 50 years. But that was something that really inspired me. I never knew who Baba was. I only saw this hotel in the early 70s. And later I found that it was done by so and so. And had this great opportunity of redoing that building. But I think the early ages, this even as a student, I was inspired by Jeffrey Baba's work. I was really fascinated. So I think that would have created me. I never want to be an architect. I only want to see how it was designed. So that created me the line of looking into how designs were done and started looking into engineering. That's how I decided to engineering and want its structure.
Okay, that's great to know. There's a question from the audience. It's an anonymous attendee. This is for Mr. Manjunath. How does the NBC and government norms affect your experiment with materials and force transfer materials?
Yeah, I think it's. Whatever you go through, okay, through your experimentation, you have to go through the courts, the Indian courts, or if you are working abroad, the British and the American courts. So, but there is always, there is a way to look at it, in the sense that most of the courts are done for a large group of people. Finally you can fight, to rewrite the code if you are convinced about your force transfer. Okay, so we do have fights with the IITs here, IISc. We struggle, we convince them, and then we go through. So there is difficulty when we choose different materials and different techniques. Okay, and so that is part of the whole agenda. So, but we have to go through this, this stringent, codal practices. Okay, so there's no way of avoiding that. So all our structure go through peer review, and there are cases where we have to force our idea and then convince it, and then we make some ready-made live 1:1 prototypes, and then explain them also.
Thank you so much, Mr. Manjunath. I think we are at the end of the hour, so I'll just hand it back to the DU team.
Thank you so much. It's important to have great synergy while collaborating. So it's very important to have interdisciplinary conversations to understand and therefore work towards projects in a cohesive manner. So thank you for this extremely insightful set of presentations by our esteemed mentors, Mr. Deepal and Mr. Manjunath. Also for being so generous with your time and sharing your work and approach with us. We are so appreciative of both your work and the conversation. I would also like to thank our moderators for the day, Vaishnavi and Shreyas, for the engaging conversation, to Mr. Azrat Sajir from Deepal Wickcremasinghe Associates, and Abhijit Manjunath from Manjunath & Co. for assisting with the presentation. Our audience, to DU and Clayworks team, have a good evening and see you on next Saturday. Kavindu from Design United will share the upcoming series of events. Thank you.
Thank you, Mr. Deepal and Mr. Manjunath, for your wonderful presentations today. Thanks to our moderators again, Vaishnavi and Shreyas, for an interesting and thought-provoking conversation. We'd like to extend our gratitude to Clayworks for supporting this webinar and all of our future webinars. So far, Design United has successfully completed 32 installments of Design Conversations, and we have many more exciting speakers lined up with designers across the spectrum joining us to share their thoughts. Next week, we're joined by Thalini Pereira from Sri Lanka, Yadvi from Studio Yavi, along with graphic designer and artist Shweta in the Design Conversation. We're also joined by more great speakers in the upcoming month, including artist JC Ratnayaka and many more speakers lined up. At the start of the new year, we're very pleased to have architect Kerry Hill and architect Tanuj from Kerry Hill Architects for our in-progress session. Do also fill in a feedback form that will pop up on your browser about today's webinar. And so follow us on our social media for our upcoming conversations. Until next time, thank you, stay safe and take care. We request our Mr. Manjunath and Mr. Deepal to stay back and give some feedback about today's webinar and DU as a platform. Thank you. So whenever either Mr. Manjunath or Deepal, whenever you're ready. Thank you.
Deepal, you want to say?
Yeah, I think I must say that after the outbreak of COVID-19, seminars became webinars. And the first experience I'm having, I have been addressing seminars, but this is the first time I addressed a webinar. So I think you all did very well. You are very organized. The entire team is very organized. And what kind of audience, what kind of numbers are you looking at this kind of session? What's the number? Hamidu, if you can answer, how many people do you think have participated in this webinar? Is anybody can answer that question?
Yeah, today at the peak we had around 70 viewers, but we had more registrations. I think around 100 or more. Yeah. And
they are all architectural students or practicing architects. What is their background?
Yeah, it varies from students to architects. and also like artists and designers, but the majority of it is students.
I think in this situation, I think this is the best way to communicate with each other because everything is restricted traveling. I think you should continue with this program in future also. I wonder whether you should get other, okay, I think is it the first time you are talking to structural engineers? Hamidul?
Yeah, Mr. Deepal, I think this is the first time.
Yeah, I feel that you should get the specialists like people who are involved in services, service engineers or services engineers also will be very useful to share their knowledge with the architect. And as Manjunath said, if you do that initially, if you can work with all service personnel and the structural engineers, the end product can be much more effective and economic. I have a feeling that integration of all professions at the early stage is important. So even sharing their knowledge will be also useful for the architect.
Thank you, Mr. Deepal. We will keep that in mind. Thank you.
Manjunath, over to you.
Yeah, it's a fantastic experience. What I feel as what Deepal was mentioning, I think as a team, I think the involving the whole team. I think we have to talk about the skill, the craftsmen, the contractors. You have to bring everybody together. I think to talk about their stories. Stories about jobs, how they executed. So I think the beauty about webinar is it's like interacting with people all over the world. You have an opportunity to ask questions, clarify a lot of things. I think you have to continue this irrespective of, this is a very good platform to express and then see, different faculties coming together, very important, designers, you have engineers, you have service consultants, you have air conditioning, consultants, a lot of people, people who are below the ground, like geology, soil investigation. So you have to involve a lot of people because the whole building is not completed without, mentioning these people. So it's very important that thank you. Yeah.
Thank you, Mr. Manjunath. Thank you.
Thank you so much, Mr. Manjunath and Mr. Deepal. It's been an absolute honor to have you on our platform. And I hope that in the future we have a lot more conversations on structural design because it's really so inspiring to see your work. So on behalf of the entire team, we would like to say thank you and we conclude the session now. Hope to stay connected because DU at its core is about connections. So we hope to see you soon again in the future. Thank you.
Thank you.
Bye-bye.
Thank you.
Thank you, everyone.
Deepal.
Thank you.
Thank you, Deepal. Bye. Bye.